Good morning, learners. My name is Mr. Paul Chilola once again, your teacher on this platform, Black Slides Online Educators. It is on this forum that you can freely come and learn different subjects and different topics, all for free, courtesy of Black Slides Online. We do not charge you any amount of money for your learning. So once again, welcome. But most important thing you can do in return is to subscribe to this channel so that should any new lessons be uploaded, you shouldn't miss out. All right, like I've always said before, I'm not alone. We are a team that sacrifice time, nothing but time, to prepare lessons and give them to you all for free. So welcome to a topic in Form 4 Chemistry, which is called rate of reaction. So the topic I'll be presenting to you this morning is called rate of reaction. There are many aspects of chemical reactions that you learn about in chemistry, in MSCE chemistry. For example, in Form 3, you learned about some aspects of chemical reactions known as chemical energetics, in which you learned that when a chemical reaction takes place, there is an associated change in energy of the reactants as well as the products. It is in that topic called chemical energetics, or energy changes, or heats of reaction as it is sometimes called, that you learned about exothermic and endothermic reactions. It is also in Form 3 chemistry that you learned about an aspect of chemical reactions which is called stoichiometry, in which you were interested in determining the amount of reactants and the products. In short, you were looking at the chemical quantities or reacting quantities, such as the mole, the empirical formula, and other aspects of chemical reactions. So in Form 4, there are also a number of aspects of chemical reactions which you are going to look at. One of them is chemical or rate of reaction. You also encounter a type of reaction which is called acids and bases. So acid-base reactions. You'll go further to study what is known as electrolysis. Electrolysis. You're going to learn about here in Form 4 what is called the redox reactions. So one of the aspects of chemical reactions which we are going to dwell on today is the rate of reaction. What comes to your mind when you hear the word rate? Right. If you thought that rate is associated with change in a quantity per given time, then you are right. So rate of reaction, therefore, is just the change in either a reactant or a product per unit time. There are different ways of defining rate of reaction, or you can look at the rate of reaction as the change in concentration of a reactant. So you must be interested in a particular reactant and product per unit time. So rate is something divided by time. So in a chemical reaction, rate refers to the change in a reactant with time, or change in a product with time. Remember that a chemical reaction has two sides. It has reactant side and product side. So during a chemical reaction, usually reactants are used up. So as the reaction is progressing, time is also elapsing, is going. So when you take the change in the reactants divided by the time it takes to bring about that change, then that's called rate of reaction. Or if you look at products being formed, you expect the product to increase as the chemical reaction is progressing. So the increase or the change in the amount of the product divided by the time taken is called the rate of reaction. We will not have this written down in this slide, just the definition. So we are saying rate of reaction is just the speed of a chemical reaction, or the rate at which a reactant is being consumed, or the rate at which the product in a chemical reaction is being formed. All right, so very quickly, we'll look at what makes a chemical reaction take place or possible. Okay, this brings us to what is called the collision theory. The collision theory. In relation to chemical reactions, the collision theory states that, it's a statement, you can be asked in an exam, state the collision theory. 1 mark for saying that. So the collision theory states that chemical reactions occur when particles of the reactants collide, okay, and they must collide with a certain minimum speed. Otherwise, they're just bouncing off one another. So the stronger the collisions, the faster the reaction. All right. So we're saying for a chemical reaction to take place, the reacting particles must collide. They must collide with minimum speed, but also they must collide with minimum energy. Minimum energy. If you go back to Form 3 chemistry, this energy which they have to collide with is what you call activation energy. Activation energy. Activation energy. So we are saying chemical reactions occur, a chemical reaction would occur when particles of the reactants collide with minimum energy. This energy is called the activation energy, or energy of activation, the energy required for the chemical reaction to start. If the particles don't collide successfully, then all they are doing is just to bombard with each other, to collide, bounce off like that, like what happens with gas particles in a closed container. Just colliding, no reaction taking place. So there must be an energy, a certain amount of energy, which is called activation energy, And it is that activation energy which initiates the mechanism of the chemical reaction. So in short, we are saying that for a chemical reaction to occur, first and foremost, the reacting particles must collide. To collide means to bombard, all right, to hit each other. Like these particles you see here, you have particles that are looking white, the diatomic particles, the white ones, these ones here. So these must collide with the red ones, like what has happened here. So in the course of the reaction, actually the collision has happened there. In the course of the reaction, the particles we are going to rearrange themselves so much so that they recombine, reconstitute themselves to produce something new, which is called a product. All right? But if they don't collide, then there will be no chemical reaction. And for that chemical reaction to happen, there must be just a small amount of energy, big enough to cause the reaction, to bring about the reaction. So once again, the main aspects of the collision theory are that particles need to collide. There must be collision. There must be collision. If particle A is reacting with particle B to form AB, then what we are saying is particle A and the particle B must be involved in some collision. So when they collision, boom, when they collide like that, the result is going to be the product. So this is A, this is B. So the result is going to be a product which is called AB. In the absence of this collision, a chemical reaction cannot take place. Let me give you an example. Suppose you want to react sodium metal with water. So sodium metal contains metal atoms, all right? Sodium metal contains metal atoms. Okay, so you have sodium metal atoms. Let's say you have sodium and the water is H2O. So when these react, we are saying that sodium metal contains metal atoms, which are called sodium metal atoms, whereas water contains water molecules. So in the course of these two reacting, when the minimum energy is attained, the atoms of sodium metal must collide successfully with the molecules of water. All right, we can consider this as this process here. So you have sodium colliding or heating with the water. All right, such that the molecules of water and the sodium metal, when they collide, the atoms, sodium atoms and the water molecules collide with minimum energy, amount of energy, there is going to be a reaction. The reaction will produce sodium hydroxide and hydrogen gas. So for this to happen, first and foremost, we are saying there must be a collision, and that collision must be successful, must be followed by minimum amount of energy, which we call activation energy. So that activation energy will cause the reaction to occur. Without this collision, the chemical reaction cannot happen. So that's what is called the collision theory. Okay? So your examiners would want you to state the collision theory. What does it state? Usually theories don't attract many marks. A theory is like a definition. It's only worth 1 mark. Okay? So you have to say a chemical reaction or chemical reactions occur when particles of the reactants collide. I've tried to shorten it so that it doesn't sound clumsy and long. Yeah, I've made it short enough for you to easily remember. So chemical reactants, when chemical reactions occur or happen or take place when particles of the reactants collide, meaning they should hit each other. So the word collide must be there. And they must collide with a certain minimum speed or energy. Otherwise, they just bounce off one another. Okay? So make it short. So you can just say, afterwards, just 1 mark. So you can just say chemical reactants or chemical reactions occur when particles of the reactants collide. Full stop. Unless you want to expand, you can say collide with minimum energy. Minimum energy or minimum speed. Don't forget to hit the notification bell so that you get notified each time lessons are uploaded to this channel. My name is Mr. Paul Chilola once again. Alright, so what decides the speed of a chemical reaction? How can you make a chemical reaction speed up or increase its speed? How can you increase the speed of a chemical reaction? Remember, the key to producing a chemical reaction is a collision between particles. Particles must collide. The reactants must collide. If the reactants don't collide, don't expect chemical reaction to take place. Forget it. So in the factors that we are going to look at shortly, on the factors that affect the rate of reaction, be on the lookout for the keyword collision or collide. Whatever factors we are going to talk about, their aim is to either increase the number of collisions, successful collisions, or to lower the activation energy, the energy required to bring about a chemical reaction must be as low as possible, because if it is high, then it is going to be difficult for the chemical reaction to happen. So be on the lookout for each factor we talk about. It's aimed at causing successful collisions or increasing the number of frequency of collisions. That's the goal for each factor of a chemical rate of reaction or factor of speed of chemical reaction. All right. So what are the factors that affect the rate of a chemical reaction? I'm sure you already postulated this or thought about it. All right. So one of the factors that affect the rate of chemical reaction is the temperature. Remember, temperature is a measure of the degree of coldness or hotness of matter. So, experiments carried out have shown that an increase in the temperature increases the rate of a chemical reaction. Okay, so if you have reactants A and B mixed together so that they are allowed to interact, okay, raising the temperature of the reactants mixture would cause the reaction to speed up. So it is not enough to simply say that increase in temperature increases the rate of reaction. You have to say why. So I've put the reason in blue as to why temperature causes an increase in rate of reaction. So we are saying the reason why temperature increases the rate of reaction is because particles gain more kinetic energy. When you heat the reactants, the particles gain more kinetic energy. Remember, kinetic energy is energy of movement of particles. So because the particles gain kinetic energy, they move faster. And because they move faster, they are going to collide faster as well. And more of the molecules have energy higher than the activation energy. As a result, the chemical reaction is going to speed up. So, they may ask you in an exam, in paper 1, explain how temperature affects the rate of chemical reaction. Such a question has 4 marks. Has 4 marks. Let's see where those 4 marks come from. So by saying that increase in temperature increases the rate of reaction, you get 1 mark. You get 1 mark for it. That's 1 mark. Secondly, because particles gain more kinetic energy, that's another mark. That's another mark. Causing the particles to move faster, that's also another mark. And therefore collide faster, and more of the molecules have energy higher than activation energy. But so the key words, the key concepts required in such a question, you should be able to say that increased temperature increases rate of reaction, particles gain kinetic energy, particles move faster, they collide faster, or you increase the number of collisions or number of frequency of collisions, and then hence the reaction increases. So for example here, let's suppose you have particles in a beaker BEA at say 20 degrees Celsius. So you have particles reacting. You have particles in a beaker reacting. Let's say that you have reactants, 2 reactants there. At 20 degrees, you can monitor the rate of reaction, the speed of reaction. Or if you raise the temperature, let's say the temperature has now been risen to, let's say, 30 degrees Celsius. This is 30 degrees Celsius. And also monitor the reaction. You find that the reaction will be faster at 30 degrees Celsius than at 20 degrees Celsius. Why? It's because at 30 degrees Celsius, particles gain more kinetic energy because of the high temperature there. As a result, they move faster, they collide faster, and therefore they have more energy. Hence, the reaction rate increases. Now, let's suppose that you have carried out 2 experiments. One at a lower temperature and the other one at a higher temperature, and plot a graph and monitor the amounts of the products formed. Such graphs will appear as shown here. So we have two graphs. We have this one here, which is in red. This represents a reaction at a lower temperature. So we are saying the reaction will be slow. By the way, this is called a reaction profile. A reaction graph, just a graph showing what is going on. All right, so this one, which is in red, shows that the reaction was slower than when the temperature was higher. So at a lower temperature, the reaction is slower, and at a higher temperature, the reaction is faster. So you're comparing the total amount of products against time. So how do the graphs show that one reaction was faster than the other? You simply consider the steepness or the slope of the two graphs. For a reaction that takes place faster, the steepness of the graph is higher. So this one is steeper than the one which is done at lower temperature. The gradient of the graphs will tell you which one represents a faster reaction than the other. So the speed of the reaction here is due to the increase in temperature. At a higher temperature, the reaction is going to be faster. The graph will be more steeper than when the temperature of the reaction is lower. So the steepness of the two graphs indicate that at lower temperature the slope is smaller, and at a higher temperature the slope or the steepness is higher. Okay, that's very important. If you're given a graph, they may just be given a graph or two graphs which are labeled A and B, and then for you to say which one is higher, represents a higher rate of reaction, suggest the reason why. So the reason is to do with increase in temperature. The higher the temperature, the higher would be the rate of a chemical reaction. And how do we know that? From a graph, the steepness. So this one is steeper. If you consider the gradient, so this one is the gradient, the graph is a bit steeper than this one here. So the steepness of the graphs are indication that the rate is higher when the temperature is higher, and the rate is lower when the temperature is lower. Don't forget to subscribe to the channel so that you don't miss on any lessons as they are uploaded. My name is Mr. Pochilola once again. Right. Another factor which affects the rate of reaction is pressure. Remember, in Form 3 physics, you defined pressure as simply force. Pressure is force per unit area. But here we are looking at the pressure of a gas. The pressure of a gas in a closed container. And strictly, pressure affects the reaction of gases. Okay? You cannot talk of pressure for solid and liquid reactants, because liquids, as you might be aware, liquids and solids are not compressible. So you cannot talk about pressure as affecting the rate of reaction involving solids or liquids. So this is particularly true for gases only. Alright, so we have two cases here. You have case number one, in which you have particles that are at low pressure. So this represents low pressure. and just call it LP, and this one represents high pressure. How do you know high pressure? The particles are confined to a smaller area or a smaller volume. Okay, it's like they are squeezed together. So because they are squeezed together, so this is B, we're comparing the two. Because the particles are squeezed together, you expect the rate of reaction to increase. So we are saying increase in pressure of gases increases the rate of reaction. Why? Okay, you have to say why. It's because particles are closer to each other and therefore there are more collisions. So it is the number of collisions that determine the speed of a chemical reaction. Particles that are closer together will react slower. It will react faster than particles that are far apart. So in A, the particles are far apart. Therefore, the rate of reaction will be slower. In B, particles are closer apart. Therefore, the number of frequencies of collisions will be high. So the reaction will be faster in B than in A, because in B the particles are close to each other. Therefore, there are going to be a high number of collisions. Alright, so if you are asked in an exam to explain how pressure affects the rate of reaction of gases, it's because when pressure increases, particles get closer to each other, so the number of collisions increases, and hence the rate of reaction also increases. Great. Don't forget to subscribe to the channel so that you don't miss on any lessons or tips that are uploaded. My name once again is Mr. Poch Lola. Alright. Another factor which affects the rate of reaction is what is called the surface area. Surface area. It is also called particle size. Particle size. So we are saying the rate of chemical reaction will increase if the surface area is increased. Let's suppose that we have in A here we have a solid. Consider this is a solid. It's a big particle, right? Let's say maybe it's a magnesium ribbon, okay, being added to an acid such as hydrochloric acid. All right, okay, so that's in A. In B, we are looking at the same magnesium but broken into small pieces and mixed or added to the same hydrochloric acid, and then you observe the two reactions. You find out that in B, where the particles are smaller, remember, smaller particles means high surface area. By the way, surface area refers to the surface of the reactants which is exposed to the other reactant, okay, or which is in contact with the other reactant. That's what we mean by surface area. So surface area is decided by the particle size, the number of particles, the size of particles. If the particles are smaller, then the surface area is larger. Therefore, there is going to be more collisions. The number of collisions will increase. Therefore, the rate of reaction is going to increase as well. So what we're saying is that crushing a solid such as this into smaller pieces, these ones, will increase the rate of chemical reaction. Why? Okay, so the reason is that larger particle or larger surface area, there is an increase in surface area, so more particles collide at the same time. I'll give you a simple example of two sorts, types of salt. Of course, my example is not a good one because it's not a chemical reaction, but it's just what? It's just a physical change, like dissolving salt. If you have kitchen salt, which is large particles, and table salt, which is smaller particles, which one, if you take equal amounts of these salts and dissolve in equal volumes of water, trust me, which one will dissolve faster? You would say that the table salt will dissolve faster. Table salt, which has very tiny particles, will have a large surface area in contact with water. Therefore, it is going to dissolve faster. Or a much more chemical example is you take a large lump of chalk. You know that chalk can react with an acid, okay, in a displacement reaction where, because chalk contains calcium, so the calcium will be displaced by hydrogen. The chalk that contains calcium. So if you take a large piece of chalk, add it to an acid, and take the same mass of chalk, but now in this case in a powdered form, add it to the same volume on acid and observe the reaction taking place. You see more bubbles forming in the reaction of powdered chalk and the acid, and less bubbles forming in the large piece of chalk. Why? Because in the smaller pieces of chalk, in the powdered chalk, the particles are smaller, hence they have larger surface area. As a result, there is going to be more collisions between the chalk particles and the acid molecules. Hence, the rate of reaction increases. All right, so once again, be mindful that how does the surface area affect the rate of reaction. You would say that when the surface area is increased, or when the particle sizes is reduced, the rate of reaction increases. Why? Because of larger surface area which is exposed, and there are more particle collisions or colliding at the same time. Very important to note. Alright. The third factor is what is called the concentration. Remember that concentration refers to the number of particles. In this case, we use number of moles divided by volume. Okay, so the number of particles, which is moles, per unit volume, can determine the concentration. Can determine the rate of reaction. Alright, so the amount of reactants per given volume, which is concentration, will decide how fast the chemical reaction will proceed. So using more concentrated solutions increases the rate of reaction. Why? Because more particles collide at the same time. If the solution is concentrated, if there are more particles of one of the reactants, then those particles confined at a smaller area will collide faster, and therefore the rate of reaction will increase. So using more concentrated solutions increases the rate of the reaction, simply because more particles collide at the same time. Great. If you have questions, don't forget to go back to the number that I gave you earlier on this in this presentation. You call me or you send me a message to seek clarification. So make sure you're able to articulate these factors that affect the rate of reaction. The last but not least is the use of a catalyst. Remember, a catalyst is just a substance which is added to the reactants in order to increase this rate of reaction. Okay? The word catalyst is coming from the word catalyze. Catalyze means to speed up. So if you're asked to define a catalyst, I'm sure you already know. A catalyst is just a substance which is used to speed up a chemical reaction without itself being consumed. So increasing the rate of reaction, we are saying a catalyst increases the rate of reaction without being changed. Okay, meaning that if you add 10 grams of a catalyst to the reactants, at the end of the reactant, you should be able to recover back the 10 grams of the catalyst, unless otherwise. Okay? Because a catalyst does not have to react with the reactants. So, how does a catalyst increase the rate of reaction? A catalyst increases the rate of reaction because it provides an alternative pathway for the reaction, which lowers the activation energy. So the use of a catalyst is simply to lower the activation energy. For example, if you look at these profiles of reactions, we have exothermic reaction and the endothermic reaction. So, in the first case, in the exothermic reaction, remember, in an exothermic reaction, the products are lower than the reactants, like shown here. So this part here, this height represents the energy which is required for the chemical reaction to take place. We call it activation energy. And you can see it is quite high. It means that for this chemical reaction to occur, we need this amount of energy, very high. So when you add a catalyst, it is going to lower this activation energy a bit down, so that you have it here, this curve here. This curve here is the same activation energy, but now it has been lowered, it has been reduced. So the chemical reaction will take place very easily. Remember, this is an exothermic reaction. In an endothermic reaction, the same is required. The energy required for a chemical reaction, remember that in an endothermic reaction, products are higher than reactants. In other words, products have more energy than the reactants. So for such a reaction to happen, we need this whole amount of energy to input into the reaction, which is quite high. So what the catalyst is going to do is to lower this, to bring this one a bit lower down, so that now the energy required is just going to be this part, this one here. Right? Then the reaction will proceed without any problems. That's the use of the catalyst to speed up a chemical reaction. Very important. All right, so of course I prepared this question for you to look at. It is saying, unfortunately it's not clear enough, but you can see, it's saying that hydrogen iodide can be manufactured from its elements using this reaction. So we have hydrogen reacting with the iodine to give hydrogen iodide. All right, Right, so the diagram shows the reaction profile if a catalyst is not used. The question is, on the diagram, draw the reaction profile when a platinum catalyst is used. So for this particular reaction, you need a platinum catalyst to lower the activation energy. On the same diagram, label the diagram to show the enthalpy change and the activation energy for the reaction with a catalyst. Great, I'll leave you here for now so that you work on this problem, and please share with me your answers, your diagram by sending to my to my WhatsApp. I'll be able to attend to you. Unfortunately, this is not clear enough, but you can zoom in and out. Just make sure you see clearly. But for now, don't forget to subscribe to this channel once again, so that you don't miss any lessons as they are uploaded. My name is Mr. Pochilola once again. See you next time.